In this video, we're going to look at Chapter 19, Section A on sign diagrams. Sign diagrams are useful when we are studying inequalities. And an inequality is not an equation. Instead, it uses the symbols less than or equal to, greater than, or equal to. Let's take a look at the graph of a function y equals f of x. Let's say the function looks something like this. First, we notice a few things. Some of the critical values, and we'll talk more about what those are in a minute, are where the function crosses the x-axis and where the function is undefined. So let's actually give those some values. Let's say that this is x equals 1 and this is x equals 3. So we have some critical values at x equals 1 and x equals 3. And we also have a critical value at, let's say, x equals 2, where the function is undefined. Now the corresponding sign diagram for this function really tells us where the function is positive, where it's negative, and where the function is undefined. So a sign diagram, essentially, we draw a horizontal axis to represent the x-axis, and we're going to make marks at all the critical values. And notice for the values where the function is actually defined, I use a solid line. And for the values where the function is undefined, I use a dashed line. Okay, and I can label those. I know that those critical values are at 1, 2, and 3. And from the graph, I know that the function is negative for all x values less than 1. So I can write a negative here. It's positive for all x values between 1 and 2. So it's a positive here. It's negative again between 2 and 3. So I put a negative sign there. And then positive for all x values greater than 3. And this is my sign diagram. And you can imagine it's very easy to draw the sign diagram when I've been given the graph. In another example, I'm going to show you how to draw the sign diagram when you're given just the equation of the function. Let's take a look at a few more functions. So here I have a nice quadratic function, and we'll say it crosses at -2 and 1/2. And let's say that I have another quadratic function that looks like this, and we'll say that it just touches the x-axis at 3, positive 3, x equals positive 3. Now it's important to note here that in the blue graph, or the blue function, the sign diagram will change at the critical values. Okay, because the graph is crossing the x-axis or cutting the x-axis. So here I have positive, negative, and positive. And this could be represented by factors such as x plus 2 and x minus 1. These factors indicate that the x-axis is being cut. In the red graph, the sign diagram doesn't change sides. Notice that everywhere the function is negative, except for where it touches the x-axis at 3, and the function equals 0 there. So on either side of that critical value, we have negative signs. And this is represented by a factor such as x minus 3 squared. So whenever you have a squared factor, the sign of the function is actually not going to change. It just indicates that the graph of the function is touching the x-axis. Whenever you don't have a squared factor, the graph of the function will cut the x-axis and the sign will change. The sign will also change when the graph is undefined. So if we have something like this, and the graph is undefined here, then the sign diagram, remember we use a dashed line, the sign diagram will change again. Okay, now we're going to look at a few examples where we don't actually have the graph of the function, but we have the function itself. For example, if we have x plus 3 times x minus 1, we can draw the sign diagram of this function. We know that the critical values are minus 3 and plus 1 because these are the values of x that make the function equal to 0. Okay, these are our critical values. So I can draw the sign diagram. I know that the critical values are negative 3 and 1, and the function is defined at these critical values, so I use a solid line. Now we try any number. I like to try 0, right? I like to set x equal to 0 and plug it in. If I do that, you can quickly see that I have 3 times minus 1, and that's a negative number. Well, 0 is right here on the number line, so the middle portion of our sign diagram will be negative, and then we use the alternating rule. Because I'm dealing with single factors here, not factors that are being squared, I know that the signs alternate, and I can just fill those in. Let's quickly look at a few more examples. Here I have minus x plus 3 squared. And the only critical value here is negative 3 because that's the only value of x that will make the function 0. So if I draw the line, my only critical value is negative 3, and it's defined at negative 3, so I use a solid line. Then I plug in, again, 0. 0 will be over here. If I plug in x equals 0, I get negative 3 squared. We do the square first, so this is going to be negative 9, which means that on the right-hand side I have a negative, but because I'm dealing with a squared factor, the left-hand side is also negative. The sign does not change. In the other example, we have x minus 1 over 2x plus 1. Here, my critical values are 1 for the numerator, and that's a defined value of x, or for the function. On the bottom, we have a critical value of negative 1/2. That would make the denominator 0. But remember, we can't divide by 0. So this is a critical value, but the function is undefined at negative 1/2. So we use a dashed line to represent that critical value. And over here, we have 1. And again, when we plug in 0, x equals 0, we get negative 1 over 1, which is a negative number. 0 is in between these two critical values. So I have a negative, and because I'm dealing with only single factors here, the signs alternate, and that is my sign diagram.